एवरीवन। सो इस वीडियो में हम ये एक नया जिम सॉल्व करने वाले हैं। तो मैंने इसका लिंक डिस्क्रिप्शन में दिया हुआ है, तो आप उसको देख सकते हैं। चलिए शुरू करते हैं। पहला क्वेश्चन है एडजेसेंट डिजिट सम्स। यू आर गिवन two numbers x and y. You need to determine if there exists an integer n such that Sn equals to x and Sn plus 1 equals to y. Here Sa denotes the sum of digits of the number a in the decimal number system. First line contains test case t, and we have take two integer like x and y such that Sn equals to x and Sn plus 1 equals to y. For each test case, print no if a suitable n does not exist. तो हमें बेसिकली एक ऐसा पता करना है कि ऐसा n सच दैट Sn x होना चाहिए एंड Sn प्लस 1 y होना चाहिए। ओके, तो लेट से हमारा Sn कोई भी नंबर है। लेट से एज एन एग्जांपल हम 70 ले लेते हैं एंड Sn प्लस 1 लेट से 71 है। तो अगर यदि इस लॉजिक से अगर यदि x प्लस 1 अगर यदि y के इक्वल आ जाए तो हमारा आंसर ऑलवेज यस आएगा, क्योंकि हम सिंपली यहाँ पे 1 से इंक्रीज कर रहे हैं। सिमिलरली एक ऐसा केस होगा जैसे लेट्स से 779 है, तो दिस कैन कन्वर्ट टू 880 सॉरी 780। इसमें मतलब लास्ट वाला 9 ज़ीरो में कन्वर्ट हो जाएगा और उससे एक डिजिट पहले हमारा 1 इंक्रीज हो जाएगा। बेसिकली इस लॉजिक से मतलब अगर यदि जो भी x है वो बेसिकली हो जाएगा y प्लस 8। यहाँ पे हमारा सिर्फ लास्ट डिजिट 9 था। अगर यदि लेट से दो 9 लेट से हमारे लास्ट के दो डिजिट 9 आ रहे हैं तो ये कन्वर्ट हो जाएगा हमारा 700 में। तो इसमें हमने 18 डिक्रीज़ किया है और एक इंक्रीज़ किया है। सो बेसिकली यहाँ पे हो जाएगा x इक्वल्स टू वाई प्लस 17। सिमिलरली जब 3 9 होंगे तब भी यही ट्रू होगा। तो इन ए वे अगर यदि x 9 इंटू सी माइनस 1 हुआ तो हमेशा ट्रू आएगा। ग्रेटर देन 0 है। एग्जैक्टली दिस, मतलब इसको हम थोड़ा वाई अगर यदि ये आता है, अगर यदि सिर्फ 9 हुआ हमारा तो ये कन्वर्ट हो जाएगा 10 में। एनीवे सेम केस हो गया एक्स इक्वल टू वाई प्लस एट वाला। तो एक कंडीशन तो यदि ये ऐसा ट्रू हुआ तो हम कह सकते हैं कि यस होगा। सेकंड केस क्या हो सकता है, लेट्स से ऑब्वियसली ये भी एक कंडीशन है जिसमें ये ट्रू होगा, वाई इक्वल टू एक्स प्लस वन। तो ये दो कंडीशन जब भी ट्रू होती हैं तो हमारा पार्टिकुलर लाइक एस एन इक्वल टू एक्स एंड एस एन प्लस वन इक्वल टू वाई सेटिस्फाई हो जाएगा। चलिए इसको इस प्रॉब्लम को कोड करते हैं यहाँ से। तो हमें एक्स एंड वाई इनपुट लेना है। इंट एक्स एंड इंट वाई। तो फर्स्ट कंडीशन है हमारा यदि वाई एक्स प्लस वन के इक्वल हुआ, सेकंड कंडीशन होगा कि वाई हमारा ये चीज़ फॉलो कर रहा होगा। तो बेसिकली डिफरेंस हम लेंगे वाई माइनस एक्स प्लस वन, वाई माइनस एक्स प्लस वन। तो ये हमारा 0 होना चाहिए एंड ये भी ट्रू होना चाहिए। यदि ये ट्रू हुआ तो ये हुआ, वरना हमारा न हो जाएगा। यदि हम टेस्ट केस को रन करें, सॉरी पब्लिक में, तो हमारा रहा यस, बाकी सब नो, जो कि रॉन्ग है। ये हमारा यस आना चाहिए था। चलिए देखते हैं ये गलत क्यों। वाई इक्वल्स टू, सॉरी फोर्थ एंड सेवन्थ ये सारा हमारा जो फिट हुआ। चलिए इस कोड को हम सबमिट करते हैं। तो ये कोड सबमिट हो गया। तो हम अपना दूसरा प्रॉब्लम देखते हैं आज के कोड कॉन्टेस्ट का। गेम विथ colored marbles. Alice and Bob play a game. There are n marbles. The ith of them has colored CI. The players takes turns. Alice goes first and then Bob. So basically, we are given n marbles and they have some color. First Alice goes, then Bob goes. During the turn, a player must take one of the remaining marbles and remove it from the game. If there if there are no marble left, all n marbles have taken, the game ends. Alice scores at the end of the game is calculated as follows. She receives 1 point for every color X such that she has taken at least one marble of that color. Additionally, she receives 1 point for every color X such that she has taken all marbles of that color. For example, suppose there are 5 marbles, 1, 3, 1, 3, 4. The game Alice takes first marble, then Bob takes 3, then Alice takes fifth, and so on. Note that this strategy is not necessarily optimal for both players. Alice wants to maximize her score at the end of the game. Bob wants to minimize it. Both players play optimally. Alice's strategy which allows her to get as many points as possible, and Bob's strategy is to minimize it. We have to calculate the Alice score at the end of the game. So Alice gets point. Alice, if she has taken one marble, she will get 1 point, and if she has taken all marble, she will take additional 1 point. So if these two conditions are true, she will get some extra points. So let's see what can be the correct strategy for Alice. So Bob's strategy is to basically minimize the score. So what will Bob do? Uh, Bob can do one thing. If like there are multiple marbles, so as soon as Alice has taken one marble, Bob can take that marble also. So to avoid Alice from taking all the marbles. And second condition is if there is only one marble left and no one has taken it, so so that one can Bob take. So let's say as an example, if color of the marbles are, let's say 1, 2, 3, 3, 4, 5, 5, 6 and 6. Suppose these are the colors of the marble. Now what will Alice do? So first Alice can do like all those marbles whose counts are 1. Alice will try those ones. So 1, 2, 4. These three marbles have one count. So suppose Alice will take 1, and for this she will get 2 points. Now Bob will try to also reduce this count also only. So it will take 2 now. Now again Alice will try to maximize, so she will take 4 and get 2 points. Now for remaining marbles the count are 2. So Bob will take any one of these marbles, let's say 3. Now Alice can try some other marbles like 5. For this first time she will get 1 point. Now Bob will also take this 5. Then Alice can take 6 and she will get 1 point. Then Bob can also take one more 6, like, so to stop it from taking all the marbles. And finally Alice can take 3 and again she will get 1 point. So final score for this one will be 7. So from this strategy, like, we can confirm that their goal is to first take the marbles with count 1 and then proceed further. So let's try to code this question. So first we have an integer n and all the colors. So we will take n as input. We have taken this as input. Since colors are between 1 to n, so we can create count of color, one array, to keep the count of each color, which will be this in this case. Now we have to calculate score. Now we will iterate through each color and see how we can proceed it. Now we will see like how many colors have count 1 and how many colors are more than 1. So we can take count greater. We can take simply count also. If count color at I equals to 1, then you can either simply count 1 by 1, else this. Now first for all the colors who have count 1. So if there are even number of those, then Alice will take half of those ones, and if they are like odd number of those, then Alice will take one more. Let's say if it is 7, then Alice will take like 4 out of those, and if it is 8, then also Alice will take 4. So for the color whose count 1, the score of Alice will become, let's say, how many? Now for those whose count is greater than 1, Alice can always take one out of those. But she won't be able to take all of them in any case, because whenever she reaches close to all of them, Bob will take out one of them. So simply score will become plus of count of 2. So the output is 6, 4 and 4. Which is wrong. We are getting 4 as the answer. Okay. Sorry. Here if yes, now we are getting 4, 4 and 1. So let's try submitting this code. In the meantime, we can open our third problem. Game with doors. Let's check it. Yeah, we can see that our second question has got accepted. Now let's move to our third problem, which is game with doors. There are 100 rooms arranged in a row and 99 doors between them. The ith door connects the room I and I plus 1. Each door can either lock or unlock. Initially, all the doors are unlocked. You know that Alice is in some room from the segment L to R, and Bob is in some segment L to R. Okay. Alice and Bob are in different rooms. However, you don't know the exact room they are in. You don't want Alice and Bob to be able to reach each other. So you are going to lock some doors to prevent that. What is the smallest number of doors you have to lock so that Alice and Bob cannot meet regardless of their position inside the given segment? So in this problem actually, Alice is in some room, let's say in the range L to R, and Bob is in some room from this range. And we know, and it is given the problem that they are in the different room. Now, now suppose, and we have to find like how many doors we have to close so that we are 100% sure that like they won't be able to reach each other. So first condition is, let's say our, in this is our number line, let's say If this kind of condition arises, we can simply lock one door. Second, very similar to this one. If this is the condition, again we can only close one door. Third can be like in which they are actually overlapping. Overlapping can be of multiple scenarios, but let's say if they are overlapping like this, then in this case we have to make sure that they don't like meet each other. So we have to lock all the doors in the between because we are not sure if they can be there also, and stop them from the end door. This will happen again if there is like another condition of the overlapping. Let's say, for an example, it can also happen like this, like L. So again, we have to make sure that they don't like get meet each other. So if there is no overlapping, then we have to simply close one doors. But if there is an overlapping, then we have to close all the doors of that overlap. Like this part complete we have to close. So yeah, so this will be like our approach to this problem. So let's try to code this one. So first we will take input. So enter equals to this. Now first we will handle the case in which there is no overlapping. So if L is greater than R, or small l is greater than big R, these are the two conditions in which there is no overlap. So we can simply print 1. If these two conditions fails, then we are sure that there is an overlap. So what is the minimum in both these cases, which is comma L, sorry, not B, we have to take maximum starting point. We have to take minimum ending point. all the doors between these ones will be closed. So lower doors will be minimum R and maximum L. Now we have to check that do we have to close the leftmost door also. So if maximum of, we can say that if L is not equals to R, similarly if L is not equals to R, then simply we can print this out. If we try to run this code, our output are 1323, 1323. If we try to submit this one, so you can see that our code got accepted. So let's try to understand the code. So this is simple the condition when there is no overlapping. So if there is no overlapping, then simply we have to print 1 because we will simply close the one door, which is this. Now this is the case of like when there is an overlap. So whenever there is an overlap, let's say no matter of what kind, in these conditions, so in these conditions we will always have to close all the doors which are of overlapping, because in these doors everyone can come. So let's say this is our like door number, let's say third, this is seventh. So we will always have to close like let's say door 4, door 5, door 6. These are the doors we will always have to close. Now we have to uh, see that do we have to close the door 3 and door 7. because can someone come from left side and can someone come from right side? To make sure that like someone come from the left side, if they both are equal, then no one can come from the left side. So this will be only happen when L is not equals to L. So this is the case in which someone can come from the left side and increase our count by 1. Similarly for the right side, this will happen, and then we finally print our answer. Now let's move on to our next problem, which is splitting items. Alice and Bob have n items they had like to split between them. So they decide to play a game. All items have a cost, and ith item cost ai. So in this problem, basically we are given n items, n items, and let's say a1, a2, a3, an. Ith item cost ai. Player moves in turns starting from Alice. So first it's Alice turn, then it is Bob turn. Okay. Now in each turn, the player chooses one of the remaining items and take it. The game goes on until no items are left. Let's say that is A the total cost of items taken by Alice and B is the total cost of item taken by Bob. The resulting score of the game then will be equals to A minus B. Okay, so if Alice has taken total items of A and B, now our score will be equals to A minus B. Alice wants to maximize the score. So if Alice wants to maximize the score, Alice will try to take out the score of maximum value, and Bob wants to minimize it. So for Bob, he will also take out the of maximum cost, and both will play optimally. But the game will take place tomorrow. So today Bob can modify the cost a little. He can increase the cost of AI of several items by integer value. However, the total increase must be less than or equals to 3. Otherwise, Alice may suspect something. Note that Bob can't decrease cost, only increase. What is the minimum possible score Bob can achieve? So basically in this problem, what Bob can do, he can distribute the cost k among all the items in such, and he has to do in such a way that he he minimize the score of A minus B. Now we know that Alice is taking the first step and Bob is taking the step 2. So basically what I'm trying to say is like first turn is taken by Alice, then third turn then fifth turn, then seventh turn, then ninth turn, and then 11th turn, and so on. Bob will take second turn, fourth turn, sixth turn, eighth turn, 10th turn, or 12th turn, and so on. And he can increase the score by at most k. Now you can understand from this, like the score of Alice will be the highest numbers, like sum of all these, like whatever is the 1 minus 2 plus third highest, fourth highest, fifth highest, sixth highest, seventh, eighth, and so on. So what will Alice strategy can be? Like to make the second element equals to 1, to make fourth elements equals to 3, and so on. I think this should be the like best strategy for Alice to follow. And in this is the only way in which Alice can actually like minimize that, like the score value. So let's try to code this problem. So we are given an integer n and k. We are also given an array ar. The first thing we can do is basically sort the array, and then we can iterate from last. Now Alice strategy is to make num1 equals to num2. And finally, like in the result, just simply adding these things. And if it is an odd number, like if n modulus 2 equals to 1, then we will also add the last element, which is element at index 0. 4 13 0 0. So as you can see that our code got accepted. Now let's move on to our fifth problem for today, that is boring day. So in this problem, on another boring day, Eager got bored and decided to do something. But since he has no friends, he came up with a game to play. Iger has a deck of n card and the ith card from the top has a number AI written on it. Iger wants to play a certain number of rounds until the card run out. In each round, he takes a non-zero number of the card from the top of the deck and finishes the round. If the sum of the number on the cards collected during the round is between L and R inclusive, the round is won. Otherwise, it is lost. Igar knows by heart the order of the cards. Help Igar determine the maximum number of rounds he can win in such a game. Note that Igar is not required to win rounds consecutively. So basically, Iger has a deck of n cards. The ith card has number A written on it. Iger wants to play a certain number of rounds until the cards run out. In each round, he will take out a non-zero number of cards from the top of the deck and finishes the round. If the sum of the cards is the sum of number of the cards is between the round between R, the round is won, otherwise it is lost. So in this case, first Iger can take 2 and 1. Now the sum is between 3 to 10. So it is 1. Then if he takes out 11, then round is lost. If he takes out 3 again, then round is won. If take out 7, then again round is won. So as soon as like from starting the sum becomes between L and R, that round is won. And we can start the new round from next point onwards. If the sum becomes greater than L to R, we can start removing the elements from the end to make it between L to R, and if it still don't happen, then obviously that round is lost. And if sum is less than between L to R, then we can simply keep increasing it. So yeah, let's see how we will do it. Okay, now we can take a variable sum, we can take variable result, take, and okay. Now if sum is less than 8, then we can simply increase the sum by AR at hand. If sum is greater than equals to L and sum is less than equals to R, in this case our result becomes 1 and sum becomes 0. Else else if submitting now. As you can see that our problem got accepted. Now let's move on to our the last problem for today's contest. That is cat, fox, and lonely array. Today, cat and fox found an array A consisting of n non-negative integers. Define the loneliness of A as the smallest positive integer k such that any two positive integer I and j, the following conditions holds: ai or ai plus 1 or till k I plus k minus 1 equals to this, where x or y denotes the bitwise or of x and y. In other words, for every k consecutive elements, the bitwise or should be the same. Note that the loneliness of A is well defined because for k equals to n, the condition is satisfied. Cat and fox want to know how lonely the array is. Help them calculate the loneliness of the found array. So we have to find the smallest positive integer k such that for each consecutive k elements, the bitwise OR is same. Okay. One conclusion we can draw from here is, let's say, suppose we are given 5 elements A1, A2, A3, A4, A5. Now suppose, let's say, bitwise OR of A1, A2 and A3 is x1, bitwise OR of A2, A3 and A4 is x2. And if and such that x1 equals to x2. Then from here this should also be true. The reason being a1 and a2 are like giving the giving the same bits, they are not contributing any extra bits, so in a way this should always hold true. So what I was trying to convey is that, let's say if the result has come true for any value, let's say v1, then it will also true for all the values which are less than v1. So using that as a logic, the best approach we can follow is like binary search, like to find the best smallest key. So okay, so for that we will first take int n and int k as an input. Sorry, and k we have to find it. Now we can take array input. Now we have to find the best k. So now to check that, like if it is true for mid, what we can do is, like there can be like several approaches. You have to see that, like for every consecutive mid, are we getting the same bitwise or? first let's try to find the like bit representation of all the numbers. As now we have find the bit representation of this, now we will store it here. Let's see. Y is greater than equals to mint. Now what we will do, if bit value is not equals to result, then we can say is result is equals to false. So if his result is true, then we can do this, and we have to check that if we can find a better mid. If and we have to put our answer. So we are getting the answer as 13355 13. Okay. For this, the answer should be 1, but we are getting is 3. Let's see why. Sorry, here we have to do one thing. If repeated by, so repeated j is greater than 0, then only we can increase the bit value, else we will not increase it. So now we are getting 11343, 1134373. So for the fifth answer we are getting 3, but its correct output is 4. So let's see. One more thing like we have to do here is, we have to remove the bit manipulation of last number. So basically bit at j minus equals to matrix at I minus mid comma j, I minus mid plus 1. Okay, so we are getting the output as 113 11344473, 11344473. So let's try submitting this code. So as you can see that our code got accepted. So I will explain this code in like this logic in simple. So what we are doing is, like we are trying to find the best possible k for our answer, and we have to find the like minimum k. So we will do binary search and try to find, let's say for, try to check for any value, let's say mid, that if our condition holds, if this condition holds for mid, then we will iterate through like as a binary search, we will iterate through like till starting till mid minus 1. So if yes, for no, it will be mid plus 1 till end. Now to check like for any particular mid, like we are whether this condition holds. Let's say we are given an array a1, a2, a3 till an. Now we will just first we will find the like bit representation of all the n, and we will see like for first mid like what is the value we are getting. Then we will check for next mid and then next mid, and so on. If all these values are same, then we agree that this is true, else this is false. And to do this, like what we are doing is we first create a 30 31 size bit array. First we keep adding their bit representation to this. Let's say if our array is our number is 4, so it is this. Mm. So this will be this. Now again let's say 6 comes, so this will become 1 and 2 and so on. We will keep adding it. As soon as we reaches like mid, we will check that if for any bit at I greater than 0, we will like calculate the value. Like let's say value is initially 0, then value plus equals to 1 at shift I. Now as soon as we reach mid, now we will keep adding next element like as we were already doing, and we will keep removing the last element like first from the starting. And to remove this, like whatever the bit representation of this is, we will remove from our this bit array. So yeah, this is the main logic. Like I can show it in the code also. First in the matrix we have stored all the bit representations. Now we are just like doing binary search, and initially we keep our answer as n. Now this is the bit array. Now for all 1 to n, we are iterating through all the elements of the array. If I is less than mid, we just find out what will be the result value, and we just add the bit representation of ith element to the bit array. Now as soon as if I becomes greater than mid, we will calculate the bit value and check that if bit value is not equals to result, then in this case just break out because all the values can't be same. And finally we just remove the like last element that was stored in the current window. And finally if result is true, then answer becomes mid, and this will finally print our answer. Yeah, so this was all about this problem. I think we are today able to solve this all the problems quite before the time. I will be back tomorrow now with another gym. Like maybe like I will try to add of for 1400 at the problem also. Till then, thank you.